Hi, my name is Angelica, and I'd like to introduce you to FlexLogger. FlexLogger is configuration-based DAX software for data logging, automation, and monitoring test execution. While you can use it for a variety of applications, it's ideal for V&V for electromechanical components and systems. This is for anything from pumps to engines to wings. Now today we're going to be using FlexLogger to simulate an endurance or a structural test application. And I'm going to be using the help of a demo box that has an unbalanced rotating fan. And so the hardware that I'm using today is a compact DAX system that features sensor-specific modules that feature signal conditioning and connectivity that match the exact sensor that you're measuring or signal that you're measuring. So for our system today, we're going to be using a 9213 thermocouple module to measure the temperature of our simulated chamber, a 9263 analog output module to control when our fan turns on and off, a 9234 vibration module to measure the vibration of the fan, a 9361 counter module to measure the RPM or fan speed, as well as a 9215 voltage input module to measure the light sensor of our simulated chamber. Now let's take a look at the software. FlexLogger contains 4 main tabs. The first one is the channel specifications tab. This is where you configure all of your analog input, output, CAN, LIN, and additional signals and measurements. The logging specifications tab is where you configure your file name, all of your metadata settings, as well as any triggered logging that you would want to perform. The test specifications tab is where you can create events that will generate outputs in response to different triggered conditions. And the screen is where you configure your UI to visualize all of your live data. So let's take a look at this system in action. When I run my test application, you'll see that it prompts me with some test properties. These are different values that I can enter that are stored within my file to give context around the test that I'm running. So I'm going to choose to enter a fan and an identification number for our test chamber. And so I've implemented some triggered logging in this case. So what you'll notice is that I don't start logging right away. I actually wait until, in this particular case, my temperature exceeds a certain threshold. And so I'm going to simulate that now. And so now that the temperature has passed that set point, you'll notice that a file has started recording, and we've noticed that our fan has turned on as a result of the increased temperature in the system, and we're seeing some increased vibration here from that fan. I can interact with my data using cursors and even choose to pause and look further into my data to explore further. And once the temperature in our system actually dips below that set point value, we'll notice that we stop logging and that our fan is going to turn off in just a second here. And so we can use events as well as the triggered logging to only capture the most important information that we're looking for. So we can see here that our fan has turned off and our vibration now has decreased. And we can open up the file that has been produced from this test. All of the files that we log in FlexLogger are TDMS files, which is an NI binary file format that's very efficient for data logging applications, but is still open and can be accessed from different applications like Excel. Once we're done logging our data, we can view that data and drag and drop and create different layouts to review our data. And we can also see the metadata that we logged initially at the start of our tests. So this is a very high-level overview of an example application in FlexLogger. If you'd like to see exactly how I built this, check out the remaining videos in this series.